Today we're going to be talking about estimating populations and also making inferences. So sometimes when you have a survey of data, usually you're not asking a question to everyone in the entire population. You're asking it to a sample. And what we're going to be looking at is a representative sample, and that would be, like it says here, a sample. For it to be representative of the population, the sample must be proportional to the population. So sometimes we're going to be looking at ratios of how many items are in the sample versus the total sample, and we're going to use that to predict how many of those items would be in the population as a whole. So we see two examples here. So we have a population of 150 golf balls, and we can see that we have a representative sample here. And 2 of these are actually orange, 4 of them are green. And the first thing that they're trying to do here is figure out, okay, how many orange golf balls would be in the population as a whole. Now what we can do is find our constant of proportionality of orange golf balls. So we can say, okay, well I have 2 orange golf balls out of the total of 6 green golf balls, so 2 out of 6, which would give me a 1 1/3 chance of something being an orange golf ball. Now if I wanted to go and figure out, okay, well how many are going to be in the basket overall, I can take that fraction, 1 out of 3, and multiply it by my total number of golf balls, which is 150, to see that I would have probably about 50 orange golf balls in the bucket, as long as it is a representative sample. Now I can do the same thing with green golf balls. I can say, okay, well there's 1, 2, 3, 4 green golf balls out of a total of 6. That's 2/3. 2/3 times 150 gives me a total of 100 green golf balls in the bucket. So using a representative sample, you can make predictions about the population as a whole. We're going to look at a few examples of this. Let's read the first example together. It says, suppose it is 200 years in the future. The population consists of humans and robots. You collect a representative sample. So here's our sample right here. And it says, if the population has 13,500 members, estimate the number of robots in the population. So if we want to figure out the number of robots in the population as a whole, first we have to start with our ratio of robots to total population, or total sample. So I can see that I have 2 robots out of a total of 10 robots and people. And so that means 1 out of 5 will be a robot. Now if I want to figure out how many robots are going to be in the entire population, I'm going to take that fraction and multiply it by the number of members in the population, which was 13,500. And when I multiply that together, that's going to give me my number of robots. Now when we multiply this, what we can always do, because 13,500 is really 13,500 over 1, I can take 1 times 13,500, which gives me 13,500, and then 5 times 1 gives me 5. I can divide those, and that's going to give me a total of 2,700 robots in the population. Now notice what we just did. We ended up taking 1 times 13,500, and then we ended up dividing it by 5. So a shortcut that we can always take when we have a fraction times a whole number is that we can take the numerator times the whole number and then divide it by the denominator to get the total number of robots. So we see that if this is a representative sample, which it is, we should have 2,700 robots in the population. Now the next question, it says, in a representative sample of 24 7th graders, there are 3 students with April birthdays. And it says, suppose there are 448 students in the 7th grade. Estimate how many students in the 7th grade have April birthdays. So we know that we have a representative sample and that 3 out of 24 have April birthdays. Now if I want to figure out the number of students that have an April birthday, it probably makes sense to simplify that a little bit to make it easier to work with. So we can say 1 out of 8 has an April birthday, and then we can multiply it by the total number of students in 7th grade. So 1/8 times 448. Now remember, just like the last problem, I can take top number times 448 divided by the bottom number, and that's going to give me 56, or 56 students with April birthdays. Okay. All right, let's try another example. So the last two examples, we're starting to look at which sample might be most representative of the population. So they give us some information about the population as a whole, and then we're going to use it to decide, okay, which sample is most representative. So they tell us you want to find the number of fiction books in your local library. There are 5,000 books in the library. You have 3 samples. The actual number of fiction books in the library is 1,500. Which sample or samples best represent the population? So sample A, we have fiction, children's, biography, fiction, nonfiction, poetry, and play. And then so on with the other groups, we have a little bit more of each of those categories. So to start off with, we want to be thinking about like what our actual number of fiction books are, and using each of those samples, what we would predict for the number of books that are fictional in the library to be. So we know that there are 1,500 books in the library, or 1,500 fiction books. And we also know that the total number of books would be 5,000. So we're going to take each of our samples and use that to figure out, okay, which one's actually closest to what it should be. So in sample A, I see that I have 2 fiction books out of 7 total books. So 2 out of 7. And I'm going to multiply that by the total number of books in the library. So just like we did in the last few examples where we took our fraction and we multiplied it by the total number, we're doing exactly the same thing here to see who's going to be the closest to 1,500. So 2 out of 7 times our total number of books, 5,000. And remember, we can take 2 times 5,000 divided by 7, gives us about 1,429 books. So 1,429 books that are fictional. Okay, let's do the same thing with sample B. So sample B, I have 12 fiction out of a total of 12 plus 15 plus 12, or 39 books. So 12 out of 39. And I'm going to multiply that by the total number of books. And again, I can take 12 times 5,000 divided by 39. And that'll give me 1,539 about books that are fictional. And then for the last sample, I can do the same thing. So I start off by figuring out the number of fiction out of the total number of books. So I have 40 fiction out of 40 plus 29 plus 7 plus 19 plus 39, or 134 books. And then I multiply that by the total number of books in the library. So I found my fraction that would be fiction out of the total number, or multiplied it by the total number, and that gives me 1,493 books. Now go ahead and figure out which of those books is going to be closest to what we should actually get, because that is going to be the sample that best represents the population as a whole. So think about if it's sample A, sample B, or sample C. So sample C was best representative of the population as a whole because it's closest to the total number of fictional books. Now something else to notice with that is that we have the biggest sample in this case. A lot of times you're going to see that the biggest sample is going to also be the one that's closest, most representative to the population, because you have more that you're taking from. Okay, in the very last example, it says an apple orchard has 874 apple trees. These gardeners each checked 75 apple trees in different areas of the orchard and noted the number of trees that are ready for picking. Each gardener used his or her results to estimate the total number of trees in the orchard that are ready for picking. So Gardener A found 11 trees ready for picking. Gardener B found 18. Gardener C found 13. And it says, what was each gardener's estimate? So on your own, I want you to try to find each of these gardeners' estimates. So remember that when we find the estimate, we take our number. So for instance, for gardener A, we are going to take the number that they got out of the number that they checked. So each gardener checked 75, and then we're going to multiply it by the total number of trees in the garden to figure out how many were ready for picking. So the work is already shown for gardener A. You can use that work and then try to find the estimate for gardener B and then gardener C. So you see that gardener A had about 128 ready for picking, gardener B 210, and then gardener C 151. Now question B says, suppose the actual number of trees ready for picking is 161. How can you use the information in the samples to get the best estimate? So we can see that all of these estimates are a little bit different, and so honestly, if we want to get the best estimate of the number of trees ready for picking, it would be best to either add up all those samples together and have a total sample out of 225 apple trees, or the other thing that we could do is just average those three amounts that we got, 128, 210, and 151. By using more data, we know that we're going to get closer to the actual amount of apple trees ready for picking in the orchard. So the second part of this notes, we're going to focus on making inferences. So an inference is a judgment made by interpreting data. So we look at our data and we come to a conclusion based on that data. Now a valid inference, if you think about the word valid, it means something that's true versus invalid means something that is not true. So a valid inference would be a judgment that is true of the population. And an invalid inference would be a judgment that is not true or is false about the population, or it does not follow from the data. So our first example says, suppose it is 200 years in the future. You collect a representative sample of humans and robots. Tell whether each inference is valid or invalid. Now our first thing there says 25% of the population are robots. So we're going to look at our representative sample, and I see that I have 2 robots out of a total of 10. Now 2 out of 10 is the same as 20 out of 100, or 20%. So it's false that 25% of the population would be robots. Now it's pretty close to that, but it still is not, it's not a true inference, or it's not true, and so we would say that that is an invalid inference. So that is an invalid inference. Now the next one, it says 2 out of every 8 members are robots. Now we just saw that there were 2 out of 10 that were robots, so this also would be an invalid inference. Now if they were to say we have 2 robots for every 8 humans, that would actually be a valid inference, but because they said 2 out of 8, that is not true. Now next one, this is a little bit more vague, and sometimes you'll have inferences that aren't so specific, and that's completely fine. So this one says there are more humans than robots, and we can say, yep, that's true. There are 8 humans for every 2 robots. So we can say that that is, yes, that is a valid inference. And then the last one, it says 20% of the population are robots. Now we found before in question A that that is going to be true. So that is also a valid inference that 20% of the population will be robots. Now our next example says a magazine company studies a representative sample of people who read their magazine. In the sample, there are 12 women and 8 men. Which inferences about the readership is or are valid? A, 60% of the magazine's readers are women. B, 8 out of 12 of the magazine's readers are men. C, more men read the magazine than women. So choose out of those 3 which are going to be valid inferences. So we can see that there is only one valid inference here, and that's letter A. So letter A says 60% of the magazine's readers are women. Because there are 12 out of 20 who are women, we could say that that as a decimal would be 0.6 or 60%. So yes, that one is going to be true. Now the next one says that 8 out of 12 of the magazine's readers are men. Now there are 8 men and 12 women, but that's not 8 out of 12, that's 8 out of 20 that are men. So that would be invalid. And then last but not least, letter C says more men read the magazine than women. That's also not true because we can see that there are 12 women who read the magazine. There's more women than men. So A is the only example that would be valid here.